Okay, we are recording week 8 of BIM 1040. This is the virtual class. It's been canceled for the live session, and we are recording this for viewing after the work stoppage. So what we're going to do is we're going to go through the content and a quick look back on where we were. So this course is building towards the creation of a full BIM execution plan. And each week we've been analyzing the components that will be pertinent to achieving this upon completion of the course. So quickly looking back, we just did a quick overview of BIM, talked about client requirements, which are really founded with the employer information requirements as defined by the UK. Basically, it's what do you have to BIM? What are the requirements being set forth by your client? We introduced ourselves to the BIM execution plan, talked a little bit about what the LOD matrices are, did a comparison between the UK and the United States, and shifted our focus to software, looked at some of the varying BIM authoring tools, analytical tools, point cloud tools that are out there, talked about how to collaborate, did a little bit more of an in-depth look at BIM uses. And during the collaboration portion, in week 5, we did an assignment where we identified a technical collaboration solution. So we looked at some of the options on how to share information models based on the particulars, the type of software, the location, geographic location of offices, things of that nature. Then we did a bit of a deeper dive into BIM uses. And that comes into importance when you're trying to understand what's trying to be achieved. And that's a difficult thing. So there, is it simple BIM? Are you just BIMing to make your deliverables and visualize and review? Or are there going to be uses of analytical, spec alignment, schedule simulation, linkages to asset management? So we talked through some of those, and those will have impact on where we are today. We'll get there in a second. Then we talked about deliverable requirements. Again, heavily impactful. Are you going to do Revit if your deliverable is MicroStation? Are you going to use ArchiCAD if you have a BIM use of fabrication driving for seamless integration with Tekla? Answers are maybe yes, maybe no. Depends on how you define your technical solution, which is where we are today. Once we finish today's session, we'll quickly look back on an assignment that opens up for this week. And the assignment basically looks at extending what it means to define a technical solution. So if I go into the week's effort, the online portion was to actually start to look at the graded assignment. So if I pop open to the assignment very quickly here, the assignment is looking at actually defining a full technical solution, basically taking into account all of this information provided. So some constraints, we've got some BIM goals that we're going to achieve. We have some deliverable requirements that have been outlined, disciplines, and some requirements set forth by the client or the contractor. And what we're asking for is a proposed solution, so a technical solution in diagram format, most likely again, for the BIM authoring tools, the review tools, and the collaboration tools. And then I said anything else that makes sense. So that grading will happen accordingly based on what you define as making sense. But what we'll do is we'll now delve into this week's presentation. And the presentation is going to look at how to actually further mold the requirements and the concepts that would help to feed into defining this sort of technical solution. So let's jump into that. And then we'll circle back, revisit the assignment again, and go from there. So on that note, let's bring this up. And what we're going to talk about today, sorry, apologies, the title's wrong, it's defining deliverable requirements based on what you're BIMing and why you're BIMing it. Keep everything of the previous weeks in mind as we go through this, specifically the software and the BIM uses. Because this kind of naturally progresses from those two sessions. And imagine when we talk through these, what softwares would be available? What's there to explore? What uses would we be trying to achieve? So focusing on architectural design for a moment here, as BIM coordinators, you may be hired into design firms, contracting firms. You may be exposed, remember the differences in project delivery. You may be exposed to design build, design bid build. And if you're on the latter, design bid build, and you're in a design firm, you're really confined to what am I doing architecturally or through my engineering practice. If it's design build or P3, you get exposed to much more of the life cycle opportunities for the project. So I describe here, you can have big BIM where everything is coming together. And some of our, in the collaboration assignment, you saw some examples. This is a treatment plant project I worked on, but you had an example, actually this was project number 3 roughly, where you have piping disciplines, building disciplines, multiple locations, multiple assets being modeled, and everything comes together in an overall whole. When a project is of this nature, your technical solution is far different than when the project is of this nature, little BIM. This is a porch redesign I did where I modeled what's being demoed, I modeled what's being built. Not much to it from a modeling perspective, but the richness of the data helped me to quantify what was being demoed, what was being repoured, linear length of rail, and I could apply many BIM uses, but scaled to a minutia of a project that it was, you know, it's almost comical to say that you could BIM something of this extent, but you very easily can. Depending on the deliverable of your projects, you could start to delve into visualizations. This was a project I did, a pump house in a golf course. Middle of a golf course. There was heavy interest in the materiality and how it looked right from the very start of the project. And yeah, without the model, conveying the message would have been impossible. There could be the flow of concept models into BIM. And I use that very carefully. So if you recall in the software, focusing on the building side, we had tools like Revit, EcoSim, ArchiCAD, Vectorworks, Digital Project. There's a whole host. But then you have tools like SketchUp and Rhino and a bunch of other tools that allow designers to convey intent, but don't necessarily follow the ISO-defined data standards and classification systems that feed into the IFC files. Now, in saying this, you may or may not be aware that SketchUp does allow for IFC export, so it's starting to attempt to bridge that gap between conceptual and BIM. But it's, you know, it's not quite there yet, but it is definitely being, you know, the divisions are trying to be closed or reduced. But there is that workflow. So when you're defining a technical solution, and I do have this a lot, I hear Revit is not fluid enough to allow me to be an architect. I need to use Rhino, I need to use SketchUp, I need to use whatever. As a BIM coordinator, we can't go in there and say, sorry, you can't do your concept design. We have to go in there with a solution to say, all right, you're doing this, and you're doing concept in tool X. We're going to be doing full BIM authorship in tool Y. I need to define a workflow to get from X to Y. And that workflow is something that it could be just testing, it could be a simple export import, or it could be an actual robust workflow in order to facilitate the needs of the project. And then that's a workflow owned and governed by the BIM coordinator. BIM focused on interior space. This was a kitchen design that I did. And I literally BIMmed the kitchen, generated my drawings, did some visualizations of intent. And again, I show this because it's your flavor of BIM. Oftentimes, you know, the myth of, oh, BIM is just for big projects. sheer and utter nonsense. BIM can be for any project size, and that's why I'm showing these examples. Even a stainless steel fabricated components came from my BIM model, which was great. Fed it straight to a cutting machine and had these panels cut instantly. And then we were able to generate quantities, and from those quantities do a rudimentary cost estimate for the homeowner. So these are all live to and from the model. So, you know, BIM based or BIM limited by size of project, it does not exist. And you got your before and after. So the conceptual BIM goal is always, you know, this would apply everywhere. And you have to remember that when you're building your solutions and you're thinking about what we're trying to achieve, there's a scalable nature of this. But fundamentally rooted in everything we do is the fact that we don't want data duplication, and we want some sort of defined workflow that allows us to get from project start to completion. That's really what your execution plan is. And I think common to any possible BIM project is you will most likely have more than one person around this circle. So as I said, it's all scalable. I may be on a project where there is no piping engineer, sure. But if I'm working for an architecture firm, there's an architect, there's got to be other disciplines, or else what are we designing? And there's always got to be a client, or else who are we designing for? So there's always some sort of interface that forces an interaction. Now, design review, if you recall with the BIM use presentation, there were three fundamental BIM uses that are really integral to all BIM projects: design authorship, design review, and visualizations. And they all kind of go hand in hand. The crux of it is you have a model, you're going to be able to do stuff with it, whereas in the 2D world, you can only do what you were limited to in the 2D world. So from the design review perspective, the concept here is, you know, not the burden, but the task placed on the BIM coordinator is to help facilitate bringing all of this stuff together. And, you know, it is much easier if you're in the world of a single application and you're working together. So this here example, this is 4 Revit models. They could be linked together and you could model around each other. Now there's burdens and drawbacks to having multiple links in your live models. So we revert to other tools. But that's why I put there, this is dependent partially on your authoring tools, because sometimes different tools behave differently when you're linking models together. And if you have projects like the examples I had in assignment number 2, I may not be able to link Revit into EcoSim or Revit into OpenPlant. So therefore, we've got to engage other tools. Enter Navisworks. One of the most common BIM review tools on the market today, thanks to the Autodesk marketing engine. The benefit of Navisworks is it could literally take a file from anywhere. And that's what's pretty impressive about it. The drawback is you lose some data. So if I have a project and I want to bring in a Revit model, an EcoSim model, Plant 3D, maybe bring in some Civil 3D, maybe some inroads, all the geometry will, for the most part, will come in and allow me to facilitate the review. That's awesome. But don't start picking at the information, because you will get data loss. And that just occurs because, you know, Autodesk struggles sometimes internally, you know, AutoCAD's or Revit definitely has some struggle pulling in SolidWorks and ArchiCAD and Vectorworks and all these other applications. The fact that geometry comes is impressive. So keep that in mind. The other option out there is Bentley Navigator. A little lesser known. I have worked with Navigator all my life. It is quite impressive. It is not as versatile as Navisworks in that it won't take every file format in, but it focuses on this concept of an I model or an information model that captures geometry plus data. So in tools like Revit, Tekla, SmartPlant 3D, you can install an iModel plugin and tell it to publish an iModel out. When it publishes the iModel, it pulls the data, or that publishing mechanism is designed specifically to accommodate accommodating the data with the geometry. Very impressive, works quite well, a little lesser known. The other concept when we're doing design review is how much of it can we do in the live model itself? So this is an example working just in an architecture firm, reviewing the impact of changing the design. So sometimes you need to review actively, the impact of what the change will do, and you can really only do that in the authoring tool. Other times, it's really about coordination across multiple disciplines and possibly multiple entities, and you need to do that by bringing the live tool into another system. Same goes on the civil end. As I said, sometimes when you go from the civil tools into Navisworks, you lose a lot of data, and oftentimes the live model review is including architectural or engineering data. Therefore, it has to be done in the live tool, and sometimes then the burden is placed on the BIM coordinator to help facilitate the form of review that can actually bring the engineering professionals together. So keep that in mind. I've seen some BIM coordinators struggle when they're faced with trying to facilitate the reviews without having a burden or without having full familiarity, if you will, of all of the BIM authoring tools and how they work under the hood in order to facilitate the actual data review. We may have reviews with point clouds. And this seems to almost always exclusively fall to the BIM coordinator when we're delivered a point cloud, and you got to figure out how to actually bring it all together. So this, I'll say, within the industry, this is becoming easier and easier as we move forward in time, but it's still quite a burden when you're given 3 gigabytes worth of points that are hopefully coordinated or geospatially located. Then you have to come and align it to the models. And you can see here in this image, this is the review, and this is what a BIM coordinator would have identified to say, hey, structural and architectural, now if I remember this is the point cloud, this is the column, or vice versa. There's an adjustment that has to be made because the model in Revit is not matching the model or the actual physical as portrayed by the point cloud. So very powerful tool when used correctly, when used with a good workflow, you've got good synergy. The other example is when we're using point clouds to validate as we're constructing. I think I talked about this last week. In the civil world, you take some boreholes that may be 10 meters apart, and we make some grand assumptions that the things are flowing from borehole to borehole. Once we remove the street and start construction and you expose what's underground, who knows what you'll find in between those boreholes. And point clouds are used often to take the scan and do a comparison back to the models to ensure that the design intent and clashes, everything are in order. Design review can often happen with collection of images, animations, assembly procedures as well. So this is taking a drawing, exposing and understanding what it is like in the BIM model, and imagining how things are going to be installed and portrayed on site. So often this is a function of the BIM lead, and when we're defining a technical solution, we have to make sure that these are facilitated. The other item is understanding how we're going to actually work and what type of mechanisms are going to be in place to either drive around those models. So that's that same one of the previous. We could be the facilitator of live review. And this is an interesting concept because oftentimes the assumption is made that we're going to be reviewing only static snapshots. This is the model at this point in time. Let's now remove, review, and analyze, versus this is the model as it stands today. Let's all sit in a room, understand what's happening, make changes live as we proceed. So that example there was a Bentley EcoSim model of a building. So it's, there's no wrong way to do review. The point is the communication has to happen. Now, just a little side note here. Part of why we do BIM is really to make our life easier. And I did this next set of a couple slides here to talk to architects about what, why are we in this world of modeling versus where we were before. But in general, when we're looking at our technical solution, I always ask, we have to know what we're modeling, what the component is, how it's going to be represented in the physical space, what data comes from the software, and then how do we uniquely identify. And these are 3 items. So, what we're modeling are very simple: door, window, wall, slab, column, duct, beam, etc. Usually that's an understanding that, if you know what you're modeling and you select the appropriate BIM authoring tool. So I'm modeling walls and doors. I'm assuming I'm using a tool like Revit and EcoSim, and I'm not using a tool like OpenPlant or Civil 3D. Fundamental thing, right? So defining a technical solution, what are you modeling? Is it a building? Is it a set of pipes? Simple, right? And then how do these things appear? So knowing what to model, that starts to get down to level of development. Are we modeling to contract documents? Is it conceptual design? What happens a lot is, are we pulling components from previous projects? Do we know what we're modeling? Have they been specified yet? Often in design, we model something that's really a geometric placeholder. So we model a window. We know length and width. We may specify 2 or 3 window vendors. So we may not know the particulars of the mullion, the width and the depth, but we have usually a maximum or a suggested. Mullions could be 50 millimeters wide. Once they get fabricated, they may end up being 45 or 38 or whatever the number is. I don't really care in the BIM world. I want to say this is a window. This will be the manufacturer as I specify. Once we get the shop drawings, we need to validate the dimensional, that it's fitting within the dimensional constraints of the design, and then it gets fabricated. So understanding this and not modeling the frivolous details, so using the window mullion as an example. A rectangle is great. I don't need to model, the actual clamps that hold the glass and the spacers and the desiccant and the sealant. I would never do any of that. This example here, the data from the software. So I'm modeling a door. I'm not going to grab the window tool and place the window on the floor and make it the height of a door, right? I'm going to place a door. Simple things like that. I'm not going to model a column, rotate it 90 degrees and use it as a beam. And I say these thinking, who would ever do that? But my goodness, that does get done. So we have to be careful of that. And then the concept of unique identification. This is an important thing because it starts to open the door to the other BIM users. If we're analyzing, we may need to ensure that the beams and columns are identifiable from each other. Definitely doors and windows need a number. Oftentimes equipment needs an identifier. Now, if you're in the world of Revit or EcoSim and we go through the IFC file, every single item is uniquely identified by a 64-character GUID. So that's good, but oftentimes we don't want to go through GUID mappings to find all the GUIDs that represent my doors. So, we don't want to do that. So therefore we apply door numbers. Unique identification. So having a strategy around that. And the burden is not on the BIM lead to define the strategy, but the burden will come often to enforce consistency. Are we naming all of our columns the same? And what parameter and Revit are being used for the column markings? Pump names, valve names, door numbers, window numbers, and then the symbols that show them, just to ensure that there's the consistency of the approach and a defined procedure to achieve it. So then when I talk through that, architects will look at me and say, well, I thought you said it's easier. Well, it is. So then I said here, imagine in 2D, maybe about 12 clicks to draw the door. And that's not fun. Same with the window, the elevation of the door, sorry. We draw the door, the section of the door. And that's a lot of drawing, okay? Then there's a spec about the door, and then there's a schedule about the door, often drawn in CAD or on a Word file. Everything's disconnected, and it just kind of sucks, right? So in 2D, we said, well, let's make it easier. We'll make blocks, in the AutoCAD world, cells in the Bentley world. And we would place these, reduce those 34 mouse clicks to a little less. We would have a master spec, maybe standardize our schedule so I don't have to draw the schedule, but I still have to input all the data. Enter the 3D world, right? Everything's parametric. Holes in the walls are cut. Components of the doors, everything's cataloged, everything's present. You modify the dimension of the door, the constraints of the door are there for the glazing and the top panels, middle panel, bottom panel, everything's there. And you do that and you say, how did we ever do this before? And I'm showing you here, here's your 2D, here's your 3D placed ones. How could we ever work not in a modeling environment? And then I say, that's just the door. And when looking at just the door and the ability to have the schedule generated from just that one door, there's your BIM. There's my design authorship, my design review, validating the type of door, my ability to visualize the door, scheduling the door, simple BIM uses, simple purpose, validating my ability to do it in the software in my defined technical solution. Very critical. What if I said to an architect, yep, use AutoCAD's generic 3D tools and make a door, extrude it, whatever. It's not the same as saying, go into a building BIM authoring platform like Revit, EcoSim, Vectorworks, ArchiCAD, place a wall, place a door, boom, magic happens. That's the benefit. And those are in the systems as we have them defined today. Place the component white once, utilize it for visualization, plan, section elevation, schedule. Parametric nature allows you to adjust. There's your BIM benefit. It's always critical, though, that we say don't lose sight of the deliverables. That's into last week's session. Deliverable requirements will have a heavy influence on our technical solution. We always have to get from model to sheet to built. This is ingrained in our AEC industry. And, I always hope one day I can go straight from number 1 to 5, go from model to built. And you're seeing that more and more. But even when we're going direct to fabrication from our BIMs, we are still seeing the need to generate drawings for validation, quality check, engineering, stamping, the legal requirements, which we're going to get into next week, that still place a burden on how we do our work today. But in the meantime, always conceptually understand we have to go from our modeling applications to a 2D representation of what's being modeled to this placement on a sheet to meet the contractual obligations. So conceptually, you slice our models up. In order to achieve this, there has to be some fundamental nature for the models to be able to talk to each other. This is why you'll hear a lot, and this is where now the technical solution sometimes can be a burden. This example here is in the Bentley world. I just link a bunch of models together, I cut, everything works quite nicely. In the Revit world, when you link a bunch of models together, those linked entities act as blobs. And you get all of the comments about, well, now we're looking to slice models. We can't control visibility graphics of the linked models because they're links. Therefore, we want to copy and copy monitor and blah, blah. You name it. Barriers placed based on the burden of the authoring software. So as the BIM lead, you're often faced with that. How do you strike that balance between where you're authoring, what you're authoring, and how these things all come together to achieve the required and desired outputs generated from the model? The benefit of tools like Revit, and actually Revit is quite well with setting color schemes and view templates so you can visualize things in a different way on varying types of sheets. Very powerful from that perspective. And that often gets pushed to the BIM lead to help coordinate as well. Simple drawings infused with 3D. And this does happen a lot as well. And we do that on drawings, and I'm seeing the changing nature of that, where the 3D view is added to the traditional plan section elevation. And that helps both with the visualization purposes of what's being shown on the plan and the schedules, but also then, you can have that level of interactivity with the 3D model as well if delivering digitally. You can have vast complexity of your deliverable, more conceptual or presentation format, all facilitated by the live deliverable, by the live linking back to the model itself. Now, details are an interesting one, because this is where, as the BIM lead, you'll be asked, what are you BIMing and why are you BIMing it? And then you'll hear, well, we have to do our construction details. And oftentimes, the discussion jumps straight to here. And as I said earlier with the window, there is no way I'm modeling all of this stuff. Just not going to happen. So oftentimes the model, probably like, the concrete slab and walls, and maybe there's a generic representation of the flat roof. And then the handrail, and then maybe a generic finish, so one component for this finish, and maybe a component for the parapet. You bring those into the detailing world, and then you'll have a 2D overlay in the Revit world, or the EcoSim, or whatever the tool is, to actually represent the finer details at the more 1:5, 1:10 scale. There has to be the proper balance between what we're modeling for BIM purposes and then what we're modeling for contract documentation. Strategies on phasing and design options as well. Most BIM authoring tools allow for those concepts to be built in. The reason I'm bringing these up here is that, often the technical solution will not only be what tool you're using, but some of the workflows within the tools to control consistency. And oftentimes I find versioning, phasing, and design options get so convoluted, especially when users don't understand what to use when. Thus, it compromises the ability to harness all that information. Now, visualization, shifting over a bit here, this is probably the most common. Almost every project will do some sort of visualization, okay? Now, I like doing this. Easy, pretty easy, much more complex, and then heavy, different workflow. And I do that because think of the technical solutions here. Models and renderings, it can be generated from the live authoring tool, or most likely you might have a tool like 3D Studio Max. Very common in the Viz industry. It can handle your renderings and your 3D animations. You might have the push to use other tools like Rhino with V-Ray. You may be asked, well, can I go Revit into V-Ray, Revit using Enscape? What about Bentley with Lumen RT? What about a tool like Lumion? So all of these come up, but often they're all focused in the Viz world, and they're not plentiful. I think in IBI's world, there's probably 5 that crop up. 3D Max is the most common and, quote, standardized, and the other 4 are here and there. They're just, we use them if there's a purpose. VR and AR, so virtual reality, augmented reality, and mixed reality is completely transformed. So we've done exploration with the Oculus, the HTC Vive, the HoloLens, Google Cardboard, Samsung Gear, whatever else that exposes itself. And there's always, what is the workflow to get from the BIM to a Viz environment, fill in the things that are missing, and then process. And that middle piece, fill in the things that are missing, are very important. Because as a BIM coordinator, kind of caught in the middle. When we get to the world of virtual reality and I strap on those goggles, I kind of want to see what it's going to look like when it's finished. But if I'm in concept design or, approaching 60%, 90%, we're still in design. We may not even know what's going to be specified yet. We're still working through things. And as an architect, if I'm not specifying the tables and the chairs, I'm most likely not going to have them in my model. I may have a placeholder to validate that the space works. Don't want this stuff in my drawings because they're not relevant to what I am being accountable and liable for. Hint on next week, right? I may have pressure to model more and show more, but I'm still an architect and I only want to show what I'm required professionally to show. So that's one one interesting challenge that the BIM coordinator has. Then you have the Viz guys that will want to show absolutely everything with the finite details of the materiality and the furniture and how things are interacting with each other so that you can achieve virtual reality, or go into some export format to feed into the physical model machine. So the physical print models usually use a format called STL or OBJ. Virtual reality may go FBX into tools like Unity or Unreal gaming engines. And all of that, you know, as a BIM coordinator, you just need to help to facilitate the workflows between the professional experts from the design side and the virtual reality side, or the Viz side. And we kind of divided into 5 levels to say, look, those first 3 are really within the control of the design teams and kind of orchestrated by the BIM coordinator. 4 and 5 kind of get you into the Max world or other tools that help to facilitate different types of workflows. This isn't cast in stone. This is just a guidance leveling that we do internal to IBI. But as a BIM coordinator, just conceptually understand that, you know, if I want to generate a view like this, most likely I just need a 3D view in Revit, and I hit the Revit engine rendering and away I go. Here in level 3, I may have, you know, V-Ray or Enscape tied to my authoring tool, and I do something like that. Or I may start to feed it off to a Viz expert, in which case a workflow would have to be looked at. Couple examples of what comes out of more advanced rendering. You know, things like this, doing this in the Revit world or the EcoSim world may be quite a challenge, especially with the, you know, reflections off of the rain and having it represent weather. So just keep that in mind. The other problem is you might be hearing, oh, the model is painfully slow, BIM doesn't work, and you go and find out, and they're doing live render mappings and heavy analysis or rendering processes that are actually putting a burden on the BIM model itself. So that's where the coordinator would step in and try to resolve the situation. 3D printing, the level of detail here required to print some of these are sometimes low, sometimes high, depending on what we're printing. And then the accuracy of these items are dependent on what's coming out of our models and being fed into systems. So defining a technical solution, again, circling back to the topic of the week, knowing the intent. So knowing the BIM use, knowing the client requirements. Is the client asking for one of these? Are we using the BIM use of visualization and we're trying to do something advanced with it? Will there be a burden during the design process? Is this happening upon completion of design? All of these things all will cater towards helping to define, again, what we're BIMing, why, and how. Now, analysis, when this creeps in, this completely changes the game, in my opinion. And this is whether you're analyzing things during design, during construction, or all the way through. So remember here, I'm still just kind of focusing on architectural alone, but the analysis here, what if I want to run an energy analysis in order to validate that my design meets the new Ontario Building Code requirements that came into effect in 2012? Sounds good. I need a really good model and an appropriate analysis tool. As a BIM coordinator, you are not a building code specialist, but your mission will be to help orchestrate getting the model from authoring tool to analysis tool. This here is Sefaria, this one here as an example. If you've interacted with that in the past. Some of these analysis tools pride themselves in saying, oh, you push a button and you go from Revit into my tool. Sometimes it works that easy, other times not so much. Structural and lighting analysis, we do this quite a bit, analyzing deflection of slabs and beams based on loading, analyzing penetration of lights, often daylighting, so penetration of daylighting from windows to the interior portions of your space. Often that's used to prove sustainability requirements. Some of these items, again, the importance, are your modelers calling slabs, slabs, beams, beams, and columns, columns? Are they mixing things up? that would have obviously a detrimental effect on our structural analysis. You may be asked to help just facilitate a transition or a translation between the authoring tool and the analysis tool. So, you know, some of those items will come into play. Lighting analysis, you might often hear it's a push button and we just want to get the Revit model out. But if you have breaks in the model, people are not connecting their ceilings with their walls, the analysis of how the lighting spreads through the space won't be accurate at all. We may be connecting to tools provided by Autodesk or other vendors in order to facilitate, for example, here, sustainability or LEED commissioning. So it correlates the data defined by the project need, what's inside the model, and commissioning efforts, and pulls it all together. This is a very old slide, so that may not even exist anymore. I've been exposed heavily to room data sheets, and we do this often with hospitals and items that projects where the rooms have a heavy programmatic requirement. So imagine an emergency room. The simple rectangular space needs hospital beds and lab equipment, piping, oxygen, waste flow, you name it. There's a whole bunch of items and a whole bunch of equipment and tools. So room data sheets, and this example is Codebook as an example, Derofus is another one, is where you can actually define which assets are required programmatically. And then they can have a relationship to, using Revit as an example, to a Revit family. And if I define the programmatic requirement, tie it to my model, to a space, it will automatically load the families to be placed in that space and then allow me, the designer, to arrange it. Or if they're already there, it will validate and verify that the required components exist within the space. I can then take that code book or the room data sheet. I can generate a room data sheet, or I can take the room data, the database itself, and tie it to other systems, potentially an asset management system. Now, shifting focus here for a moment to the engineering side. Believe it or not, everything I just talked about was potentially just architectural. So you can imagine defining a technical solution. It's not just enough to say, all right, we'll use Revit if there's other requirements. Same on the engineering side. So I showed this on previous weeks. Electrical, mechanical, and structural are full engineering disciplines, usually that interact with architectural, coming together, create this whole slice and dice. Quantities, clash, deliverables. This is your typical. I cannot imagine any type of building without all these disciplines at play. They just don't exist in the world. On the civil side, I showed this before, you could have plan and profiles. You might be asked, what's the best application to do efficient plan and profile drawings? Well, it's not Revit. It's not EcoSim, but an easy answer would be Civil 3D or Inroads or OpenRoads. But we've gone through these in previous, but this is just a reminder on the engineering side. Other than building engineering, you know, linear infrastructure engineering is very heavy and very much as much BIM as buildings are, if that makes sense. So I'm just reminding you of all of these aspects, all of these tools, the potential that exists to pull these all together. So that's kind of a reiteration. Bridges actually come in heavily where they are linear. They're almost like buildings in the linear environment. So there, when you're doing bridge work, you'll actually see an interesting fusion of BIM authoring tools from the building side as well as the civil side. GIS comes in, and this is all about your geographic information of the assets themselves. So I've done a lot of work in the past with tools like Esri, ArcGIS, and other custom tools that merge geospatial mapping coupled with asset-based information and geotagging of either point cloud data, geotagging of images, and it all comes together into a whole. IBI does some work with site data management. So this is a fusion of CAD files brought into a site data management tool, allowing us to analyze and control information pertinent to parcels of land, for example. So if you were a BIM coordinator on a project like this, what ours would be faced with is we have an online web-based tool developed by our intelligence practice. We're going to be developing layouts in AutoCAD or Civil 3D, and those are workflow to get from our authoring tool, Civil 3D, into this online database. And there's a connection of information or a connection of data between the DWGs and this online database. So we would have to query with the database owner to understand, do you just look at PDFs of CAD files? Are you able to interpret block data? Are you able to interpret attributes? And what are the tying points? So this is an interesting aspect of BIM because it's actually nothing to do with a building-based 3D model, but a full connection of 2D-based layout coupled with an online database. So again, don't lose sight of your deliverable. Same concept from the engineering perspective. You got to go from model to documentation in today's world, slicing and dicing. Start to get into some interesting parts though. Oftentimes we're asked for quantities, and whenever we're dealing with quantities, often, the biggest ticket items are your steel, concrete, and pipes, usually. Now, when you think of traditional buildings, steel and concrete are still the biggest items. Architectural finishes come into play often as well, but infrastructure, industrial, concrete and steel come up all the time. And what we look to do is, again, remember that 4-step. What are you modeling? How do you model it in your component? And what's that unique tag? And the unique tag versus the default tag, whether it's an object GUID assigned by a BIM authoring tool versus some type of unique identification that's built into the system, defined maybe by the owner's asset management requirements or by the contractor's purchase order, the contractor's logistics team, who knows? And we're often able to identify what we're quantifying. And this example is an interesting one. Other times we're saying we may have, the cost estimating BIM use, and as a BIM lead, we're asked to provide quantities. And I've come across this many times. Here's your volume of concrete. The answer, that's not good enough. I need to know what type of concrete. And the reason is the cost of concrete is coupled with the rebar and the formwork, and there's different multipliers for where the concrete is. Is it a slab sitting on grade? Footing versus foundation? Elevated slab? Elevator pit slabs? Elevator shaft walls? Stair shaft walls? Are they bearing? Are they just dividing walls? All of these types of poured concrete all would have a different cost, which is why delineating, in using the Revit example, walls, floors, roof, etc., and then delineating the materiality to be concrete or not, and then further delineating some sub-parameters to allow us to quantify in different mechanisms is heavily valuable. Often we're asked to help facilitate change management as well, and this is change via visualization. So you may be asked as a BIM coordinator, oh, there's an adjustment that has to be made. I can't visualize it. Help me see it so I as an engineer can help assess the change. Do I move the pipes away from the concrete? Do I move the pipes to center them on the concrete? Can the pipes be in the concrete, or do they have to be in the grading so that they're accessible? What are all those questions? You don't know as a BIM coordinator, but that's just the clash that we would identify. And then we can start to help them visualize the impact of the change, the impact of what's surrounding. Maybe as a piping designer, I might say, well, I'll just shift the pipes. It's nice and easy. But as a BIM coordinator, we'll say, hey, if you move the pipes, look at everything around. Here's all the models together in Navisworks that may impact the design decision and avoid clashes and make it more of a quality decision for down the road. So very powerful. You can see the difference there of just moving the pipes if I'm looking at structure versus, hey, I've pulled everything together. If you move the pipes, you might have an interference relative to the outfall of this tank. Maybe this is a reserved clear space, therefore the pipes can't move into here, and the dialogue ensues. Very powerful. very influential as well. So that's a very important aspect of our role. Same with the design review concepts. It's comparing what are we doing? Navisworks, Navigator, other. I didn't list on this slide here, but keep in mind Solibri as a review tool harnessing the IFC file. So that's an interesting workflow and an interesting technical solution that you always have to consider. Are we reviewing based on our live BIM authoring tools, or are we reviewing based potentially on OpenBIM? And OpenBIM is powerful. For the most part, your data from buildings flow. You may have a struggle with engineering data. So as they continue to refine and enhance the ISO standard that governs the IFC file, going out of these proprietary tools, Autodesk and Bentley, to something else like the IFC file and thus into Tekla BIM sites, Solibri IFC viewer, makes it far more viable in the years to come. The other thing to focus on is how do we deal when we have heavy intelligence in our models? So what do you do as a BIM coordinator if you say, we're working on a project in Australia, I need to see the Australian steel selections. So as a BIM coordinator, you may not even know that the steel selections are different in Australia versus UK, Singapore, England, Canada, US, etc. So I'm showing this example. This is from Bentley's EcoSim. And I know you can do it in Revit as well. But in here, I like it that I'm able to use my structural placement tool, and I'm able to expose which selections I want. So Australian one steel versus Australian cold form profiles. And then I get my different looks, all my UK profiles, my standard US. That has a significant impact on the data in the structural model, how that data is analyzed, how it gets fed into an analytical system, etc. And it's funny because this is heavily dependent on the BIM authoring tool and something that we could mess up very easily. It could just be we have the wrong selections, the model starts to get built. It may be dimensionally right, but it could be the wrong form or the wrong section, and therefore it could analyze completely differently. Revit, oh, here we go. So in the Revit side, the family of steel sizes are built into your family. So again, we're able to select the right family. The crux is we've got to know where the project is so that it's being modeled correctly. And oftentimes this is missed. And we're using the wrong sections for the wrong geographic location. And if we're doing structural analysis or structural quantification, though that information is incorrect, if not validated. The export of intelligence on the structural side, there's a couple of export mechanisms that we can go through in order to get to a structural analysis system. And then it allows us to analyze beams, columns, slabs for deflection, analyze it from mobile devices. Yeah, I think I think the point's been made here. So, if you're working with structural engineers and we know that there is this integration of BIM structural data to a structural analysis tool, we have to ensure that the flow of data is facilitated. I talked in previous weeks about plant-based schematic data. So this is a P&ID, a process instrumentation diagram. And in the P&ID, it allows us to show all the varying assets. These are all the valves, pipelines, major pieces of equipment. And I think I described in previous weeks, this flow here that I'm showing in the middle of the screen, that could span multiple buildings, maybe even multiple sites. But the flow is represented in a schematic. We can query it all and then analyze it, tie it to an asset management system, and importantly, tie it back to the plant model. So if we're defining a technical solution, we know there's intelligent plant schematics. They don't tie into Revit and Civil 3D, OpenRoads or EcoSim. They tie into tools like AutoPlant, OpenPlant, SmartPlant, Plant 3D, CADWorks, and others of that nature. Running analysis, so structural analysis and quantities. Here's an example where the analysis application feeds back into the information model, and as you make changes, they can feed back and forth. You can quantify, analyze accordingly. The ISM is a Bentley term for an integrated structural model, and it facilitates the exchange of structural data either from Bentley or Autodesk authoring tools. So I can go from Revit through ISM into tools like STAAD and RAM and other Bentley-based analytical software, and we have that flow of data and analysis to and from. So here I'm showing AutoCAD to ISM to an analysis tool and back and forth. And it's the back and forth that's intriguing because oftentimes that's compromised. Again, we talked quickly about this analysis. I won't dwell on that. Mechanical analysis through tools like Saphera allows us to take models like our Revit models, our EcoSim model, feed them into this online system, and facilitate the analysis of heating, cooling, efficiency of wall sections, stuff of that nature. So, BIM coordinator, you look at this and say, I don't know any of that. I agree. As an architect, I don't either. But as a BIM coordinator, I can say, if our models aren't getting from authoring tool to this analysis tool, I'm going to grab the owners of this analysis tool and say, why isn't our model going through? Get some feedback. Maybe we might have to go to Autodesk or Bentley or our software vendor and say, hey, how do I fix this? Maybe I have to go to our disciplines and say, you guys are modeling wrong. Model correctly. You called a wall a piece of glass by mistake, and therefore the heating load is astronomically horrible because it thinks it's a piece of glass going up the entire building when in reality it's not. So all those things, and it's very easy in the BIM world to completely mess up the analytical portion just by having an error in the selection of materials. Pipe stress analysis. Here's an awesome one. We're defining a technical solution. I, the piping designer, want to analyze my pipe stress. Right away, that's just a trigger saying, okay, I need a plant-based BIM authoring tool. Pipe stress analysis, P&ID integration are two triggers to say, get away from building and civil and find plant. How this works is it allows me to define my workflow, my material, probably whether it's pressurized versus not pressurized, and then allows me to analyze and adjust accordingly. Very powerful to understand how my pipe's going to deflect based on the speed of the flow within the pipes. This bottom left image here, if I had something, so if I design this as an architect saying, hey, I need a space here to walk through. And then we say, well, you need 1200 millimeters clear, but I'm going to have a 300 millimeter deflection on my pipe through when the flow's occurring. Well, that's not going to work well if I have people walking through here and the pipes are going to compress. So very powerful tools when they work well. Electrical analysis happens a lot. How do I analyze my cable trays? First of all, model my cable trays. How many conduits are in the cable trays? How many wires are in the conduits? All of that's possible, and all of that's possible in tools like Revit and EcoSim as we stand today. And then are they linking to an electrical schematic analysis tool? So linking to something like PromiseE, something like AutoCAD Electrical. And if they are, what burden does that place on us as BIM coordinators to orchestrate the ability for these tools to talk? And then how are we collaborating, right? How are we sharing Revit relative to AutoCAD Electrical, and where are all these players going back to assignment 5, week 5 assignment? So again, it's what are we trying to do from a BIM use perspective? To what degree are we analyzing? Think back when I talked about all of the examples of construction back in week 2 and 3. How are we facilitating all of this? And we talk about linear infrastructure, above and below grade. What type of models how are we doing this? Are we using Civil 3D, and to what extent? Who's defining the piping catalogs? How are we sharing those catalogs? Keep in mind those Civil 3D data shortcuts and how those DSPs are being stored, shared, and authored from. Are we modeling just to visualize? Are we going to try to pull asset management assets from these components to bridge into asset management systems? Are we looking to do cut fill calcs? So are we going to have to expose surface models or subsurface models and have those integrated into tools like Navisworks? Are we connecting to a GIS system? So, talk about what GIS is. I alluded to this earlier. It allows users to query, interpret, and analyze spatial data layers. That's the easiest way to mention that. If we're doing that, how are we connecting? Is it for a urban planning perspective, analyzing land use? So non-building focused, very macro level, larger scale. What tools are we using? Are we infusing with a system like ArcGIS? Are we collaborating globally on that system? Where are our GIS specialists and how are they connecting to the data and who's feeding them the data? Municipal asset management. Are we just connecting data layers together and exposing them to be viewed? And maybe what I'll do here is let me pause for a moment. I'm almost at the end here. But I wanted to show a live example of GIS. And let me actually do that for you here. So here, we'll go to this example here. And this is an example of ArcGIS Online. So this is why I keep asking, be cognizant of what we're doing. This is a quote quasi-simple. It's showing, as you can see here, proposed streets, lot lines, showing some utilities, so domestic water, where your sewer structures are. So a lot of this information was done in Civil 3D and fed into this GIS system. I have the ability with this system to turn off the components I don't want to see. So maybe I just want to see the pipes. So I'll turn off the structures, the lot lines, and I can start to now see my pipe network. And I can potentially interact with these pipes if I wanted to. I see the data as pulled over from Civil 3D, and I can make some decisions as a owner or an asset manager relative to what I'm seeing, how these proposed pipes are interacting potentially with the overall greater infrastructure. If I wanted to then turn everything back on and see my interaction with the surrounding on the barriers of the development site. So there's a lot that can be done here relative to just having a simple interface feeding my data into the GIS world. And I keep describing GIS as data layers. So remember that. It's layers of data that are interactable and allow me to feed and understand what's happening from an overall perspective. So that's just a little taste of ArcGIS Online hosted by the Esri World. So I'm not going to dwell anymore on the GIS side, just for the sake of time here. So just to close this live session, I put a lot out there today, but it's really to sort of show that it is a convoluted process, but to bring it down to the actual feasible nature of how do I define a solution? That's what this is about. How do I go into a project, possibly cold, not understanding what the driving factors for the project may have been, define a solution, influence a team, influence a project's member scope, schedule, budget, and influence my designers, influence my project managers, potentially the interaction with the contractor, ensure I'm delivering what the client needs, etc. So I always say, can you answer these 10 questions? There's a lot of questions here. So what are the owner requirements? So you're brought into a project right off the bat. What does the owner want? The answer is, I don't know. That could be a risk, right? Oftentimes your answer is, the owner is not involved, they just want a PDF. Easy, that's good, because then you're really BIMing within the confines of the project. So that's okay, right? You might hear the owner wants a Revit model, the owner wants CAD files, the owner has an asset management system, the owner wants us to infuse something in their GIS system. We deal with that. Then what are you BIMing, why, and how? So depending on the answer of question 1, then it's, who are our teams? Where are we? What's the price? Is it a building? Is it a transit? So think of those 3 project examples I thought that I gave in week 5's assignments, right? High-rise building, transit project with multiple facilities and linear infrastructure in between, rail, utilities, etc. Plant project, multiple buildings on a plant campus with yard piping and process flows. Those are 3 distinctly different types of projects, and that would, without knowing anything else, that would garner some initial thought on what the technical solution could be. Then it's, what are my BIM goals and uses? So again, why are we BIMing? Go to the project manager. Some project managers will say, I don't know any of this technical stuff, we just have to meet the budget. Others will say, we know we're doing BIM, we want to make a difference, but not too much, right? Just the right amount of BIM. Others will say, let's make a difference, let's make this an award-winning, technically advanced, blah, blah, blah. Get an idea there. Then you start to define your BIM uses. Again, it's always design authoring, design review, and some form of visualization. Is there anything else? How are we sharing information? So what geographies are involved? So remember the 4 steps to collaboration. What are we sharing? With who? So then I can lead it and be accountable. Those are the most important questions. What are we sharing and with who? Is it India, London, Toronto? Is it, Toronto and Ottawa? Is it internal only, or more importantly, internal and external, thus most likely driving us to the cloud? What are our deliverable requirements? So the owner may have specific requirements from question 1, but it just might be a general, yep, we have to deliver DWGs and PDFs. We have to deliver our Revit model. What are the questions? What design disciplines are involved? Arc, struct, MEP, civil, piping, chemical, process, acoustics, corrosion, land development, urban planning, GIS. What are the disciplines? Who are the stakeholders? Construction, communities, owner, design team, operations team, value engineering. What software is needed? Now look at that, defining a technical solution. 8th question, what software is needed? You cannot, and I've seen this often, we're doing BIM, great, Revit, done. You cannot do that, and I can't stress that enough. And I always say, the answer may very well be Revit, but get to the answer by asking the questions first. With question number 8, what software is needed can be coupled with, are there any restrictions on software? Licensing, availability. So Esri is a great example. We're going to deliver to GIS and develop a GIS database. Well, Esri's got some very unique software licensing restrictions. Do you have licenses? Do we have to buy licenses? All those questions have to be answered. And that couples into number 9. What's the team comfortable with? Bentley EcoSim makes the most sense because it's a DGN deliverable and the client prefers that, but there's not a stringent requirement. The design team at large is far more Revit comfortable. So what do we do? Can we get from Revit to Bentley? Personal experience? Yes, you can, but there needs to be a strict workflow and it needs to be complied with. Is that the right solution for the project? Maybe. What's the form of project delivery? PBB, DB, P3, IDP, you name it. Australian Alliance. What is it? If you don't have an answer to any of those 10 questions, your technical solution will be flawed. Now, for the sake of this assignment, I kind of drove you towards all the information you need for the week 8 assignment. In the real world, You may not get answers to all 10 questions, and therefore you'll be taking a BIM risk in developing a potentially flawed technical solution. Now, with experience and good judgment and good ability to guess well, you may be okay, but be mindful that it's risky. Once you have the answers, you document. The BIM execution plan is a documentation of your approach. It's very important. So week 5, we looked at the collaboration solution. Week 8, we're going to look at the technical solution in a diagrammatic form. We're going to move into legal and BIM use workflow diagrams. We're culminating with creating this execution plan based on the project criteria. That's where we're getting to the end of this course. And then we execute, keeping in mind scope, schedule, budget. Very important. BIM does not happen outside of project delivery. You have to always remember that. BIM is not this ominous special thing. It's a part of the project. And a great deal of my work in the last decade and a half has been interacting with project management, helping to define scope and budget, and ensure schedule can be accommodated for that. Okay, so with all of that said, and I know that was definitely a lot, looking back at week 8 here, you know, we're going to talk about this this assignment, this graded assignment that is now exposed for everyone to see. So the outcomes of the assignments are talking about so the selection of appropriate collaborative and software tools that are required for a specific project. Okay, so what I'm looking at here in these instructions, and I briefly went over at the beginning, this is the criteria. So this is in theory, the answer to those 10 questions. And similar to the collaboration exercise of week 5, what I'm seeking here is give me a diagram again of a possible working solution. So the focus in week 5 was 3 different projects, just focusing on how we're sharing. Here, there's going to be most likely 2 diagrams, your collaboration diagram and then your software diagram. And that's showing what authoring tools are we using to achieve these BIM goals. And the BIM goals, okay, we want to, you know, the various design disciplines. So all of these disciplines will be attempting to achieve some form of those goals. Now, what's the trick, right? Couple tricks. Notice the deliverable, PDFs in 2D, doesn't care what format. They'll accept either one. This is a huge thing. And this is very luxurious, if you will, because most often that is not the case. I, as the client on this project, are saying, give me whatever CAD format you wish to give me, but I definitely want a CAD format of your 2D deliverables. I want an IFC of the building in sight. I want an asset list. And I want the data to be compatible to go into my GIS system. So what are my tricks here? An asset list. Most likely that's just something like Excel or Access. Incorporation into my GIS system. Most likely that's going into a system like Esri. The biggest trick is right here. You got to define some technical solutions. So, if you're familiar with Revit, sounds good. Revit is not the technical solution for all these disciplines. Therefore, when you're defining what I'm design authoring, you have to give thought to landscape, civil site, and civil utilities. Okay? Now notice I made this an elementary school specifically. So in this project, I didn't want to get into the plant, the PNIDs and the pipe stress analysis and the plant authoring tools. Wanted you guys just to focus on building and civil. Buildings and civil. Okay? That's the crux of this. So you read through this, you do your diagrams, buildings and civil, multiple BIM goals, notice the viz as well. What are we using for viz? Some idea. Max sounds pretty good. Let me know, right? Schedule simulation. We touched on this weeks ago. You know, am I going to simulate with Navisworks? Maybe Vela, maybe Synchro, anything's on the table. And that's why I'm curious to see to what extent, or based on your previous experiences, what are some of the things you can expose and put forward as well. And that's it. So hopefully you've enjoyed this, this session. And any questions on this assignment, obviously I'm always available, and we can field live questions when classes resume. Thank you everybody, and have a great day.